Hi everyone, welcome back. I'm Joe DeGiorgis. Today we're going to talk about the concept of motion blur in photography. Okay, so if we go back and talk about the four variables of exposure, which consist of ISO, which is the sensitivity of the camera sensor or film, the aperture, which is the size of the pinhole, which we refer to as f-stops. And we said that f-stops not only control exposure, but also control depth of field, shutter speed, which we're going to talk about today, and the light itself. So shutter speed also controls more than one variable. Obviously, it controls an element of exposure, but it also controls motion blur. So if you have an object that's moving very quickly across the field of view, then to capture it in full sharpness, you need a very fast shutter speed, like maybe 1/400th of a second would stop the action. But if you want motion blur, that is, you want to see the action happening, then you would use a slow shutter speed like 1/50, 1/25, or slower. So if we go back to Sunny 16 and we're taking a photograph between 10 a.m. and 2 p.m. on a bright sunny day without a cloud in the sky, we can set our ISO at 100. Of course, our f-stop needs to be f16. It's the Sunny 16 rule. And our shutter speed at 1/100, which is the reciprocal of the ISO. And if we take a photograph of our subject during the daylight hours between 10 and 2, it will be properly exposed. But now, if we want to see motion blur, if we want to see a blurry race car on a racetrack, then we need to decrease the shutter speed. So we could go from 1/100 to 1/50, and that would be twice as much light in terms of exposure, but the shutter would stay open longer. We could go to 1/25th of a second, which would let in, again, twice as much light. From 1/50 to 1/25 is letting in twice as much light. And we could go to 1/12.5, and that would be twice as much light as 1/25. But from 1/100 down to 1/12.5 is 2 times 2 is 4 times 2 is 8. So this is 8 times the amount of light. So we're going to be able to capture motion blur because this is a relatively slow shutter speed, but we have to compensate now for this increase in the amount of light. We can't change the ISO because we are at the least sensitive setting, which is an ISO of 100, which is the best image quality. So we can't play with the ISO to compensate for the 8 times the amount of light. We could change the f-stop. Most camera lenses have an f-stop of f22 as the smallest aperture. So in this case, if we move from f16 to f22, that's half the amount of light. But if f22 is the smallest aperture, that's the only thing that we can do to compensate for the light, and there's still way too much light entering the camera, so our image would be overexposed by 2 stops. The other option is to purchase a neutral density filter, which acts like sunglasses to block out some of the light from entering the lens. The filter screws on to the end of the camera lens, and you can purchase variable neutral density filters, which allows you to increase or decrease the amount of shade that the filter provides so that you can block out enough light so that you will reach the proper exposure with a shutter speed of, in this case, 1 over 12.5. So we've talked about the 4 variables that control exposure: the ISO, which is the sensitivity of the sensor, the f-stop, which is the size of the pinhole or the aperture. There's the shutter speed, which is a door that opens and closes and lets the light in, and you can vary how long the door stays open. And then finally, light itself, and that's what we're photographing: light and how it interacts with the subject matter. So that there's only 4 variables, which is unfortunate, because if we had more variables, there would be more flexibility, more creativity in photography. It turns out that although there are 4 variables, there are times when all 4 variables are not at your disposal. For instance, if you're shooting the sunset at the Grand Canyon, then you're not controlling the light. You're relying on the ambient light in the environment to take the photograph. Now, it's true that you could wait until the next morning and shoot the Grand Canyon at sunrise, or you could wait until noon and photograph it then, or maybe you'll find a time when it's cloudy versus sunny. But if you're just there for that one moment and you're trying to capture the image of the Grand Canyon, then you do not control light. If you're involved in studio work and you photograph inside a dark room using studio strobes, then the shutter speed is no longer a variable for exposure, and the ISO is no longer a variable for exposure. What you do is you set your shutter speed at 1 over 100, you set your ISO at 100, you set your f-stop for depth of field, whatever you would like. If you want a shallow depth of field, maybe you would shoot at f4. If you want a very deep depth of field, you might shoot at f22, or you could shoot somewhere in the middle, like f11. But you're not using the f-stop to control exposure. You're using f-stop to control the depth of field. And then you use your strobes and you increase or decrease the power to the strobes, that is, increase or decrease the amount of light, and that's how you control the exposure. If we're doing microscopy, we no longer have f-stops because the f-stops are part of the lens. And we've removed the lens and we've added an adapter that allows us to connect the camera to the microscope. And it doesn't have a variable set of f-stops in the adapter. For sure, there is a pinhole, but the pinhole is fixed and it's determined by the microscope objective, the 5x, the 10x, 20x, 40x, and so on.